So welcome to 2001. It's Intro to Theory of Computation. So what we're going to do today is quickly go over the administrative details and let you know the various things that you're supposed to do this term. And I have, I guess I have a bunch of slides which are a review, just overview of the course, and we can either do those or not. I mean, we don't need to do them because there's a recording of me doing it last year. So on the screen here, you see the course webpage that hopefully you figured out how to get to already. The link is up there, and it has all of these various links at the top. So the link to Jeff just brings me to my homepage, and then course information has everything to do with this specific term. So let's go over to that page. So this is courses 2001, as opposed to the other one had syllabus on the end. So what do I want to encourage people to do is to turn on the video. And I have to say, we're doing really well so far. There are a bunch of nice faces up there. And so that I feel like I'm talking to somebody. And definitely, anytime you have questions, just speak up. If you put up your hand or something, I may or may not notice it. So you can just turn off your muting and say, hey, I have a question, and then we can talk about it. One of my course reviews during COVID said that we were very cliquish in this class. You know, there are lots and lots of students, but it was very cliquish. And I tell you, what you have to do to be part of the clique is you have to talk to me, right? Because there are a bunch of you on the screen. If you turn on your video, then you show up on my screen. And if you talk to me, then I hear you. And quite frankly, everybody else, you know, we don't know about them. Yeah, and you might feel intimidated by talking to professors, but the truth is, right, I'm just some guy who's been doing this for a while, and you don't have to be nervous about talking to me. All right. There is a forum in which you can ask questions and answer other people's questions, though I would say the last year or two, what happens is people do that kind of thing on Discord, and so not that much happens on here anymore. If somebody has a Discord page, you can send it to me and I will link it to the web page if that's helpful. So in this course, I've taught this course many times, and now I have recordings of every little topic from previous terms that you can watch. And so what we're going to, so I guess there's the whole thing about, do you do things on your own or synchronous or asynchronous? And what worked really well last term, the last two terms, is everybody watch the videos on their own. And then during class time, we just chatted. So sometimes, so if you have questions, we answer questions. And I guess what happened last time is when people didn't have questions, I kind of gave a few more lectures on, and some of those then were uploaded. So there are plenty of lectures to watch. And if people don't have things to say during class, then we'll chat about something else. All right. So about tests and in exams, I was told at some point during Zoom that having exams that you have to write at home is extra stressful, and that we should work on having lots of small tests instead of having a full exam. And that seems to have worked pretty well. So we're going to have a bunch of tests and no exam. And let me tell you, a real strong advantage of that is that though we'll have more tests throughout the year, so you'll work more throughout the term. When we have our last class, we're done, right? So you can be studying for other exams, right? Other courses. So that's kind of nice. It's the tests, all the tests. I can't monitor what you're doing when you're at home. So all the tests will be open book. Though I do try to make the questions hard so that you can't just Google the answers, right? And I ask you, try not to search for answers other places. So I've always had tests be an hour and a half because we have an hour and a half class, right? But so I'll keep designing the test so that I think you can write it in an hour and a half. But different people have different schedules. Maybe somebody's zooming in from Mumbai here. So I'm going to give everybody, I'm going to give a 24-hour, actually, I think it's changed to being longer than a 24-hour window in which you can do the tests. And then people then ask, well, is the test only an hour and a half, but you can do it when you want? And that would be way too complicated. You have an hour and a half to do it. You have 24 hours to do it. What's the other thing is I ask people to work in partners. Why is that? Well, because people are probably talking to each other anyway. So, cheating. So if you're a person who doesn't want to cheat, then I want to give you sort of as equal rights as people who are talking to somebody. So the idea is you can talk to one person. All right, so here again about your partner, right? You work in pairs. I don't want you to feel isolated. I want it to be fair to everybody. If other people are talking to other people, you need to be able to talk to somebody as well. The best way to learn material is to teach somebody else. So ironically, you might think the way to get a best mark is to have a student, a partner who's really smart, but having a partner that you can teach the material to is probably the best way for you to learn the material. Now, when you're, even during test times, during the 24 hours, I'm open to you talking to as many people as you want, right? You can talk to each other, you can talk to your friends about the material as a whole, right? But the request is that you don't give test answers to anybody but your partner. And quite frankly, it's in your best interest because your mark isn't based on the mark you get on a test. Your mark is based on the mark you get compared to other people, right? So don't share test answers. And let me emphasize, I don't mean when you have a partner, I don't mean you split the questions in half, right? Each of you should do all of the questions and work on them together or share. Maybe what you do is you each do all the questions and then you get together and you share to see if you have the same answers. Here's just a little technical glitch. Every test, there'll be couple people who start answering questions before they put their partner's name on the test. All right. There's no reason to post answers on CrowdMark until, the last minute, right, just before it's due. So the problem with if you start answering questions before you put your partner's name on it is that then you can't put your partner's name on it. it refuses to let you change. So if that, try not to have that happen, because there are a lot of you, but if it does happen, then don't panic. The person whose name is on the work can email me and say, hey, I did this with Bob. Here's Bob's address, email, and I will add them to the list. All right. If you, so to get a partner, if you know people already and have somebody you want to work with, then that's great. I will post, I haven't done it yet, but I will post a list of everybody's name and a list. So, and then a list that will say, I want a partner. So if you want a partner, you take your name and you put it on that list. And if you need a partner, you either take somebody's name off that list or, right, you put your name in there and somebody will contact you, right? And here's a little emphasis. When my first term handling partners, I didn't say this. And I got so many emails about people having troubles with their partners. And so just don't email me about your partner, right? So I guess maybe up here I didn't say it. If you feel your partner didn't contribute to your work, and you can tell your partner that you're not going to add them to the test. And if you really, really don't want a partner, I won't force you to. But all right, if anybody have any questions, you can holler at any point.
Professor, you mind if, Professor, can I ask a question really quickly?
Anytime.
Just to reiterate regarding the test policy you had, so we have the full 24 hours to the full time frame to do it, correct?
Yes.
Okay, so it's not like you start the test and you have 1.5 hours to do it?
No.
Okay,
No.
thank you very much for that clarification.
The thing about the 1.5 is that's really just the guideline for me. So really it's how long I would make the test if you had an hour and a half to do it. But the truth is, every time I've done this take-home tests, during Zoom, people spend most of the 24 hours on the test, right? So people fill all available time. So any other thoughts?
Hello? Hello?
Yeah, I'm here.
Hi. So I just had a quick question about the partner thing. So like there's a list where you can put your name and then somebody will get in contact with you?
Yeah, so I will make a list that if you want a partner, there's two things you could, and you don't know people.
Mhm.
You can either go to the list of people who say they want a partner and email one of those people,
Mhm.
or you can add your name to the list and hope somebody emails you.
Okay. And then also, so like the tests, if you have a partner, you can put your name and your partner's name on the test. And then for the mark, you guys both get the same mark, right?
Exactly.
Okay. Okay, perfect. Thank you so much.
You don't have to do have the same partner for each test. You can have a different partner for each test. And you can fire your partner, and that's what we got.
Okay. Yeah, and if something goes bad or something, each person can just submit their own test. Worst come to worst, right?
Yeah.
Okay.
So that's kind of why I another reason I said, you have 24 hours, so you don't have to start logging into CrowdMark the first 10 minutes, right?
Mhm.
You can work on it together, and if you decide that you want to fire each other, then you submit it separately.
Okay. Sounds good. Thanks.
That I will admit that another motivation of this is because we have a limited number of TA hours, and if people work in partners, then there are fewer tests for the TA to mark, and the TA can spend more time with each test, right? So that's another motivation, right?
Okay. Yeah.
So I'll tell you something I don't want people to do. In fact, this is kind of what we said you could do, and now I'm telling you, you can't do it, is don't work with your partner and then submit 2 different tests, right? Because you didn't do it alone, you did it with your partner. So only then deviate if really you got, if it turns out one person really didn't do anything, or don't be submitting someone else's work under your name if
Yeah,
you're
yeah,
there, right?
okay, makes sense.
Philosophy of this, right?
Yeah.
All right. Okay, now to talk about the marking scheme. We can count how many tests there are. I forget, maybe there were 6 of them. So I'm going to basically take the average of the marks of the tests. But what I did last term turned out, well, not last, yeah, the last time I taught this, it turned out to be a disaster, in my opinion. I thought I would be really nice to you and said that your worst mark doesn't count. And then what way too many people did is they didn't write the last test. So I didn't like that. So now I'm going to be nice to you, but a little less nice to you. So whichever test you do the best on is going to be worth 1.5. And every test you do the worst on is going to be worth 0.5. Right? So if you bomb a test, it doesn't matter quite as much. All right. I'll tell you, I love teaching, and I love chatting with people. The things I like the least is when I have to remark things. So the TA will mark it. The TA doesn't necessarily do the best job. And if you really feel that, not that, if the TA gave everybody a low mark, then it doesn't matter. But if you feel that you really were disadvantaged, then I am willing to remark it. But let me warn you, I have a couple kind of rules first. The first is really, really make sure that yours is right before you give it to me, right? Check with your friends and stuff. Check with the solution set first, because if you ask me to remark it and it's wrong, then I will nail you, right? Because you got it, in my opinion, you got it wrong once. You got it wrong when you wrote the test, and you got it wrong when you thought yours was right and the TA marked you wrong, right? So I will very well lower your mark. Yeah, and also I guess I forgot to say that here, but if you get, according to this, if you send me, you want me to remark something 20 minutes after I post it, then I won't believe that you did this, right? So wait a day or so to at least pretend that you're studying it before you get me to remark it. Okay. Here's another thing. I wrote this particularly because when I taught 1090 last term, 60% of the class got an A. And the university has a rule that I can't give more than 30% an A. So I lowered some of I still gave 40% an A, so it broke the university's rule, but they wouldn't let me give 60% an A. So I'm just specifying here that this mark here really doesn't have any meaning, right? You get a 70%, you get an 80%. It has no meaning, because what I'm going to do is first, that if one test people do really, really well on it, then I'm going to scale the marks for each test so that the average and the mean are the same for each test. And then I'm going to sort the students based on that mark, and then I'm going to just decide how many gets A's and how many gets B's. All right. As a general rule, I fail I don't fail all that many people. I've generally failed like 5 people out of a class of 100. And maybe a 9th gets an A+, and about a 9th gets an A, and about a 9th gets a B+. All right. I have this other thing, which maybe I should remove it here but when you only have an hour and a half to write the test, and people, then leave a question blank because they didn't have enough time, then I give people 20% for a blank question. But it has an extra purpose in that if you write something and it's really, really wrong, if it's sort of insultingly wrong, then I'll give you a 0. But if it's blank, you'll get a 20%. And similarly, if for some reason you fail to write a test, well, getting a 0 is pretty harsh, right? So I give people 20% for blank tests. Any questions about tests?
So I had a question about the partner thing.
Yep.
So if we have a partner, we already know like before like doing the like asking somebody else. So like pretend I have a partner in mind already.
Yeah,
we
yeah.
just go into this. We just go into the test and we just write their name and then that's it.
Yeah.
Okay. Thank you, sir.
Yeah. If you have a friend that you want to work with, then you don't have to worry about finding a partner. When I first started this, I had this thing that I would assign people random partners, but that was just added to the nightmare of it. And part of my goal in life is to minimize my personal nightmares. All right, so timing, if you click on times, you get my schedule, and you probably know this already, right? We're from 4 to 5:30 Monday, Wednesday, and Thursday is the tutorial. But the truth is there's not much difference between these because we're just chatting anyway. This is the dates file, and here are all the dates of the term. Here's the tests. All right. So I've got tests scheduled from 8 a.m. on Thursday to 11 a.m. on Friday. And I guess I wanted it before I had it until 8 a.m., but people were staying up all night. And so I thought if we stretched it a little bit, then people wouldn't have to wake up at 8 in the morning to submit it. Anyway, that's a pretty healthy time period. And then you'll see during this tutorial, the tutorial from 4 to 5:30, it falls within this block, right? Now maybe this isn't good because that means there are a lot of hours between when you get it before you talk to me. Last time I did this, you got the test, and then a few hours later, you talked to me. So actually, maybe I'll change this. Maybe I'll change the test from 2 p.m. Thursday until 2 p.m. Friday, or 3 or 4 p.m. Friday, so that you have a chance to talk to me right away. I think I'll do that. All right. See, everybody understand what I'm saying? So at this period from 4 to 5:30, we're going to have a tutorial just like this, in which people can ask questions about the test. In fact, what I did before was I kind of actually give a lecture reading the test to people. And I was surprised to learn during this process just how much of a challenge people had with reading the question. Somehow, if I read it and chat about it, people understand it a lot better than if they read it themselves. All right. So I'm going to change this test time so that it's closer to the tutorial time. All right. So what else do we got here? All right, so now, if you go to the syllabus, there's all these topics, right? Lots and lots of different topics. And each topic at the various times in purple, it says when I expect you to watch these videos by. All right. So September 13th, I don't know when that is, about a week from now, on the Monday, I expect you to have watched these videos, right? And so you can see it in this chart here, right? September 13, S is for September, September 13, you're supposed to watch these various videos. And here I have the total number of time, the amount of time in those videos. So this one is a little longer than the others, partly because I'm just sort of getting us going. So the total number of, if you look at the times of all these, it adds up to 4 hours. And then this symbol here with the earphones is the video from last year that you're going to be watching. So if I make any video special for this year, I will post them with this thing. And some videos have this symbol, and that means you can watch it if you want more details. It's going to be a longer thing recorded from. So I used to cover more material, and I've been decreasing what I expect from you. So this would be a recording of when I taught more, or I taught it in longer things. And sometimes what this is this was the video from when I was in class, and what I've posted here was the video from last term when I chatted about it more. But what was and the X's here, this one is when I don't have a video for that topic, but I don't think there are very many of those because we filled them in last term. And one thing I can ask you is if you find one video isn't as good or doesn't work, or you watch a different video and you like it better, or you like the video that we did in class, then let me know and I can update them for future years. Okay. The other thing is part of the reason I've sort of shortened things. There are a couple of reasons I've shortened things. The one reason is I found that this course was just too esoteric, had too many hard proofs, and I was complaining about it since I first started at York. And but people said, "Oh, these other professors need it." So then at one point, I'm embarrassed to say how long it took. I finally went and asked these other professors, and it turns out that when they teach it, they didn't teach the hard proofs. So I started cutting out some of the hard proofs. And the other thing is I'm leaving a couple weeks at the end because I hope to do some machine learning, because students found that they enjoyed that. All right. Here's another thing is some people find watching the videos to be slow because they're on a slow internet. And so their video doesn't quite work as well. Maybe you're in some other country. So if you click on here, it took me about a day to put this together, so I hope that somebody appreciates it. It's a zip file of everything. So if you download that and unpack it, it should act like the online thing, except it will be local on your computer. When we chat here, like right at this moment, I will post the new videos. I'll put them up here. Right? I put them up here unedited. If if something seems particularly good for a topic, I might add it down below. So it'll only go down below if it was, cut out for a topic, but just our chats will be put in these new videos here. This is just said about these slides. There are thousands and thousands of slides. Don't print them because that'll take too much time. And if you find any typos or mistakes, let me know. I guess I was saying, be sure to come to class, but now we're Zooming. You can, in fact, on that topic, people ask, are the tutorials required? Are the lectures required? I'm going to say that nothing's required. You come to class if you want to chat to me about the material. And if all you want to do is listen to the posted videos, then that's perfectly fine. And if you want to listen to what we chat about, that will be posted on the video as well. So you're flexible to do what you want. Oh, there's a table of contents at the top of the video, of the slides. Don't print them. Keep track of typos. Come to class. All right. Any questions? Are people good here?
Professor, I have a question.
Yeah.
So on the table that you indicated the tests, kind of the schedule,
Yeah.
I didn't understand what those, for example, right beside T1 is TM. What does that mean? DFA, NFA.
Oh,
What are those?
you see Turing machines?
Oh, okay.
So here you're watching videos about Turing machines, and then test 1 will be about Turing machines, right?
Oh, I see.
Here you're doing material about DFAs, right? And then test 2 will be about DFAs.
Okay, and what are those ranges, like 0.00? Is that like, are we following a book here, or is it
Oh,
like sections from?
right. So see this slide right here?
Oh, the slides. Okay.
So here, here you're supposed to, right now you're supposed to watch between 2.1 and 2.4. So if you come up here, it's 2.1 to 2.4.
Oh, okay. See, thanks.
Does that make sense?
Absolutely. Thanks.
Right. And the truth is, this is everything about Turing machines, right? So you'll note on Monday, September 13th, you're supposed to have watched the videos about Turing machines, right? And then look what happens. We have a class, a class, a class, a class, a class, a tutorial, and then that's where your test is, right? So the idea is that you watch the videos between this class, and then we have all these classes to chat about it, right? And then you'll have a test, right? Compared to the DFA stuff, here DFAs is 3, right? So you're supposed to watch DFAs this time. Oh, I lied to you. See, there's two. Turing machines is 2. So you watch some of it here and some of it here, and then there'll be 2 more classes and then a test. That seems more, right? You follow that? And so here then you watch DFAs here and here, and then there are then there's a class and a class and then a test about DFAs. Right? Does that make sense?
Yeah. Hi, Professor. I have a question.
Yeah.
Actually, I have 2 questions. So, firstly, I'm sorry I must have missed it, but could you repeat the course breakdown, like what percentage each test, etc., will be?
Okay, we have 5 tests, and the tests that they're all, first assume they're all worth weight 1.
Okay.
And then the test that you do the best on compared to other people is not worth 1, it's worth 1.5. The test that you do the worst on is worth 0.5.
Okay.
And that's it.
Okay, thank you. And the other question was, so those lectures that you posted that had the explosive sign on it, which meant it covers more than it's needed. So do we have to watch all of them, or do we have to watch part of them?
No, the whole point, video covers more than needed. That means you don't need to watch them,
All right.
right?
Okay, thank you.
But it is on the topic, right? They were lectures that I gave previous years when I covered more material. So, so it's possible that you'll want to watch them in order to get a deeper understanding of the material,
All right.
right? I mean, maybe we could say if you're wanting to do really well in the course, then if you watch the extra things, then maybe it would be good for you, right? Oh, also, I guess another thing I found is that some people tell me that they watch my videos over and over and over again, right? So if you're going to be watching the video 3 times, then maybe the second time you'd want to watch a different one.
That makes sense.
Right.
Yeah. Thank you.
Any other thoughts?
Professor, do you mind if I ask a question about the material in the class?
Oh, well, yeah, we're getting to that in a minute, but yeah.
I was just going over the introductory slides that you posted about predicate logic. I just had a question about computability. Like basically, is a problem computable when like you have some machine and some input, and the machine's output is like the expected output?
You're getting way ahead of yourselves on this right now. But I guess tutorials we can ask questions, but a problem is computable if there is an algorithm that on every input gives you the right answer.
Okay, thank you very much.
Sir, can you, so we have all the symbols. What does the Winnie the Pooh mean?
Oh, I think it means nothing.
Nothing, just.
I think I just was looking for symbols and I thought about using a Pooh Bear symbol and then I never used it.
Ominously there. Just... Nothing, never mind.
Yeah. It looked a little small. Wasn't standing out as bold enough, so that's why I didn't use it. But I love Winnie the Pooh, so that's why I kept it there. Any other thoughts?
Sir, just to clarify, so our mark is completely made up of the test, right?
No.
Thank you.
Yeah. Yeah, because there's no exam. And in the past, I've had participation marks, but while we're Zooming here, it was just too hard for me to keep track of who's participating and who's not. But I'll tell you, I think I did say somewhere, I hold the right to increase the mark of people who participate. So I will try to keep track of the people who talk to me, but it's hard to do during Zoom. All right, so course material. This is the list of the topics that we'll cover. And I have been teaching it a long time, so I do have a lot of material. So this column are the PowerPoint slides. So for example, that if you click on that button right there, it will give you the slides that we are currently looking at, right? It's the intro slides. Then here are, I had a bunch of questions and solutions that, and then somebody, so here's a bunch of questions, here's some solutions to those questions. And then at one point, somebody convinced me to post an old test. So I think this might be the 2017 exam. So you can look at it and its solution. And so all of these buttons down here, you push on it and it brings it up, right? And so what I recommend doing is you try the questions before you look at the solutions. and you kind of, and one option is to do that before you come to class, so that one of the things we could do in class is chat about some of these problems. All right. This is just cut out of the course calendar. So before PowerPoint existed, I started typing up some notes, and they're here, but there's nothing in the notes that aren't in the PowerPoint slides. So my recommendation is you just look at the slides. Mental health, many of us certainly struggle with mental health. And when we're all locked at home at Zoom, it can be harder. So take care of yourself. And if you need support with anything, talk to people at York, talk to me, talk to whoever can help you. E-class. So what you can get there, what will be available on E-class is maybe, actually people tend to not get the test there. They got the test from that Mark thing. What is that called? Anyway, the CrowdMark, that's it. But you know, you can get marks here as well. You'll get your marks from CrowdMark. You'll get your test from CrowdMark. So I'm not quite sure what you're going to get from E-class, but it's there. Right. So there's the Zoom that you're all on. There's a forum which people can ask questions. But I think I've said already that you can put if you give me a Discord thing, I'll add it right here. Link to get, yeah.
The thing about, like, just a couple of slides ago, you like, I got, I don't, well, what was my question about? Yeah, so I wanted to know whether you were going to send us a link to the CrowdMark.
When there's a test.
When there is a test, yes.
Yeah.
Okay, thank you.
Right. In fact, I always do it ahead of time, and CrowdMark has this thing where I can say, email it to people at this time, and then have the cutoff at this time. So CrowdMark does it. CrowdMark emails it to you automatically. And if you're not in the class, we'll talk about that. Did I say this already? I have no power to get you in the class. All right. But you can attend class, hoping that you'll get in the class at some point. So if you're not in the class, then you won't get a copy of the test. But if your partner is, all right, is slow, and I'm, all right, so there's where I'll put a link to a file that lists people who want to have a partner. And this is what I just said is the class, the last I checked, the class has 155 people in it. They're not supposed to be bigger than 100. I'm personally happy with anybody being in the class, but I seriously have no power to get you in the class or not get you in the class. So it's their job. And so don't bother asking me if I can let you in the class, because I can't do it. Right? So that's what I said. I guess this little note here talked about you mail to the undergrad office if you want to try to get in the class. You mail to audit if you want to get into E-class, even if you're not in the class, and you can just watch these Zooms, right? There's really not much on E-class other than. All right, so then this is again saying, what are we going to do during our time here, right? You should by the month. So then I was told that if I make you watch 2.5 hours of videos, then I don't need to meet with you as many hours, right? So if we don't meet all this time, that's coming. So as long as people show up, I'll talk to you, and we can talk about the material. You know, we can review things, you can ask questions, practice tests, get ready for the tests, and we can skip some. This says, if you email me, I'm teaching 2 courses, so I already get emails that say, ask me about a course, but tell me which course you're asking me about. I like pictures because I don't remember anybody's, I don't remember what people look, their names. All right, any questions about administrative things? I'm going to go with no. So the rest of these slides, I guess these are sort of things like, one thing I found is that people take coding courses, courses where you're supposed to code, and they spend hundreds of hours, they spend so much time coding, but they spend less time on these theory courses. And my request is you spend as much time on your theory courses, and you try to read ahead. Well, now we don't have lectures, so it matters less, but you try to think ahead about the material. And when you hand in your tests, try to proofread them. You have 24 hours, so proofread your tests before you hand them in so that they're readable, right? And one thing I say here is that the way we test you is not based on what you know, but how well you can explain things. And the best way to learn the material is to explain it to, practice explaining the material to somebody else, or even to your Pooh Bear. Right, so this is just saying, read the solutions. Before reading the solutions, try solving them yourself, and get help, So the solution sets are very similar to the types of questions that will be on the tests, right? So if you, since it's an open book, you can go back and look at those solutions and copy them. So it makes life a lot easier for you. During a test where you have to memorize things, it was useful to kind of memorize the solution, really understand the solutions through the things that I posted, because the test questions would be similar.
Excuse me, sir.
Yeah.
Is it that you would give us assignments that are not mandatory, but are still similar to the test?
Yeah, remember I showed you that list of questions. Those aren't mandatory. You just do those as you want.
Okay.
Right.
So those questions are the questions that are similar to the test.
Yeah. So the test that I had posted there, this course, there's not that much room. The test questions are pretty similar year after year, right? I try to make them a little different so that you can't copy them from previous year. And please, don't give one of the things I hate in the world is those websites that post solutions to my tests. Never give those to try not to make my tests available to anybody outside. But I do have, I do try to come up with new questions every year.
Hi, Professor.
Yeah.
I think you said something about having to enter a Zoom class for a test. Does that mean you have to be in a Zoom meeting during the test?
Sorry, I didn't hear any of that. Just say it again.
I think you said something about us needing to be inside a Zoom meeting in order to gain a test or something like that. Could you just clarify that?
Yeah. Yeah. So I'm going to move the time of the test slightly so that you get the test. You first read the test at maybe 2 o'clock in the afternoon, and it gives you a chance to read over it. You read over the test and think about it. And then during our tutorial time, from 4 to 5:30, we will have a tutorial, right? We will Zoom it, and people can, and we can talk about the test. The only thing that I really, really request is that you don't give answers during the tutorial, right? You don't say, question 5, is the answer 8, right? Because now everybody knows the answer is 8.
Okay, So suppose we understand the test perfectly, then do we need to attend that tutorial?
You don't have to, I kind of said you don't have to attend anything.
Okay, great. Thank you, sir.
Yeah, you know, during a normal test, if we were at school, we were in a classroom, some professors don't let you ask questions and some do. I'm always of the form, people should be able to ask questions. So that's what the Zoom meeting is about, is so that you can ask questions during the test. Now you can still email me as well. You know, if you have a question, you could email me, and I will try to keep up on those emails during the test. Any other thoughts? So this is all about abstract thinking, recorded in the other recording. So we could go through these slides, which is an overview of the course, or you could watch the video from last term on the overview of the course. What do people want to do now?
I think an overview of the course material would be cool.
All right. As I said, you could watch it. Your topic will be, it's a model tape. And you might think, use Java. Why do we need to learn about a Turing machine? And the one is that it has some historic. Two, it teaches us how to think abstractly, which I think is useful. Learning how to think abstractly is useful. It's definitely not practical, right? So I think most professors, that's kind of cumbersome and hard to do in itself. But what I try to do is try to take and put on top of it layers of meaning so that you can see how do I get intuition and meaning from these abstract and a Turing machine. We're going to first write kind of pseudocode. I call it Java code, but it's really just sort of pseudocode and compile it into a Turing machine, right? So every test I've ever had on this subject before, certainly in the last many years, and I've made up your first test. Give you Java-like code, or I describe the algorithm, and you have to write the abstract Turing machine transitions. You have to describe this Turing machine. So that's the first topic, about finite state automatas. So they happen when the input comes to you like a stream, right? Maybe you're playing Mario and the world comes to you like a stream, or you're a calculator and people push buttons like a stream, or you're looking at, you have a job queue and the jobs come one at a time. And as they come, you need to process them. And so this is actually one of the topics that the various people in the department were keen that students learn, is because say you're in engineering and you want to build a Coke machine, then you want to say, well, my Coke machine's in this state, I receive an input, I move over to this state. Then I'm in this state, I receive an input, I move over to this state. And so it's ways to think about a machine as moving from state to state, right? And it's good to have different ways of representing the same thing. So this is just saying for proving theorems, and it's good to have different ways to thinking about an algorithm. But they're less practical. You're not going to be doing this in a job site necessarily, but having this way of thinking about it will give you ways of I think it'll help you in your computer science world in general, right? So then another topic is regular expressions. You use sets and unions and concatenations and clingy star, and you can define various languages, right? And now we're getting into theories, which we could have prove lots of complicated theorems. And instead of going into those theorems in real depth, the proofs in depth, the new slides are more and more just sort of sketching the intuition behind the theorems so that you don't have to worry about it quite as much. But there's this class of languages, what a DFA can do, which is a deterministic finite automata, is the same as the set of problems that a non-deterministic can do, which is the same as the set of problems an extended regular can do or regular expression can do. So writing a compiler that will take in a non-deterministic finite automata and compile it into a deterministic one, or compile it into a regular expression, or or take a regular expression and compile it into an NFA. So is you can mechanically translate from one type of machine to another. The next topic I really love is context-free grammars, so here's a grammar which says, what is an expression? It's a product of factors. A factor is either an integer, an expression in brackets. So that's a grammar. And back in my day, back when I was a kid, the textbook for a language and the back had the grammar for it, but I don't see that anymore. I don't know why Java doesn't have a grammar in the back, but anyway, a useful thing is given your Java program or given your English sentence to be able to parse it and to say, why is the expression? Because this is a term and it's adding to this term. So an algorithm which I think is very beautiful is how to take a grammar and a string and parse it, building a parse tree from it. And that's what compilers are. And if there wasn't a good algorithm for doing this, then we wouldn't have compilers and we wouldn't have computer science as we know it. Right, so what's the advantage of having a grammar is it helps you add meaning to parts of the string. It helps you process the string. If you use Microsoft Word and you type some sentence and it underlines something in green because it thinks your grammar is bad, what Word is doing there is it's building a parse tree. It has a grammar, an English grammar in there, and it tries to parse your string. And if it doesn't parse it, then it underlines it in green. And certainly, as I said already, being able to translate these, what does a compiler do? It takes a code that's written in Java and compiles it into code written in machine code. And so being able to translate between these is what is all done by a grammar. And again, students resist it, but I do think the topic helps you understand things that are useful in computer science. All right. Another topic that we're supposed to cover is how many integers are there? How many fractions are there? How many reals are there? Cantor really got people, mathematicians, riled up when he came up with this. And I have lots and lots of slides on it, but I've narrowed it down to just a quick understanding of it. Though yesterday I did make some more slides for this topic. So here, basically, what's true about integers? Each integer can be described by a finite string, right? No matter how big the integer is, there's a finite string that describes it. And similarly, each fraction, what's a fraction? Like 3/8, right? It's described by a finite string. And hence, well, the number of finite strings is the same. So the number of fractions is the same as the number of integers, right? But most reals require an infinite string to describe the real, right? 0.13821, it goes on forever, right? And so there are more reals than there are fractions, more reals than there are integers. And that's kind of interesting. By doing this mapping, right? We map each integer to each fraction to an integer, but instead we're going to, yeah, in fact, this stuff here I've cut out. So here, this is the proof that there are more reals than integers, right? So here's a list of all the reals. And what we do is we if you try to list all the reals, right, if you try to count them, if you try to say this reel is 1 and this reel is 2, then I would construct a new reel that wasn't in your list to prove that you haven't counted them all. But we're going to be skipping this anyway. Then we get into the question of what's computable, right? Somebody asked this already today. Question is, are there uncomputable problems? And in order to do that, Turing question is, we define the set of computable problems, or those which is equivalent to those that can be computed by a Java program, because we can compile from a Turing machine to a Java program, from a Java program to a Turing machine. I'll teach you how to compile back and forth, right? And Turing proves the halting problem is a problem where I give you the description of an algorithm, say a Turing machine or a Java program, and we want to know on a given input, does it halt, right? So Turing proves that there's no algorithm to solve the halting problem. And then this here is Jack Edmonds, and one of the things he defined was poly time versus exponential time. You know who this is right here?
Is that your dad?
This is my dad, and that is not my dad. That's me. Mm. So, so these classes of what can you do in poly time, what can you do in exponential time is kind of interesting. And then we're going to look at a class of non-deterministic polynomial time. It's the famous open problem in computer science. It's the difference between how long does it take you to find a solution versus how long does it take to verify. If someone were to give you the solution, can you verify quickly that it is a good solution? So we'll study that sort of topic. And then one thing that Cook problems are complete, meaning if you could solve them, you could solve all of them. So SAT is the problem. I give you a circuit and I ask, is there an input that makes the circuit output yes? And then we're going to do reduction. Say if you had an oracle to solve one problem, then you'll design another algorithm to solve another problem using this one as a subroutine. So we're going to spend a certain amount of time doing reductions, right? Right, given an input to this other problem that we have an oracle for, the oracle will tell us the answer, and that will help us get the answer to our problem. I like to spend a little time on Gödel's incompleteness theorem. It's not part of the course, but it's way cool. But if you take logic from me, we'll do that there anyway, so maybe we won't. And so this just says, and it's good to take complex things and think about them in simple ways. I don't know why that was suddenly that slide was there. And then machine learning. I wanted to be able to teach machine learning to you guys, and it suddenly occurred to me one day that this course is the theory of computation, and what is machine learning? But it's the method of computation, so we can cover a certain amount of the theory. And it's changing our lives, right? Machine learning is changing our lives. It's where the jobs are, and if there are any jobs left, that is. And York is starting a whole new program about it. And so our plan is to teach some in this course. So a couple years ago, I got approval from the chair to do 2 hours of machine learning in this course, but I've been making it a little longer every term and nobody's complained. So currently, if you look at the schedule, we have 2 or 3 weeks that we can do in machine learning. And I think so far people have always enjoyed it, right? So hopefully it'll help you get a job, help you understand the world. I find the whole topic oddly spiritual, right? How can you do this simple task and create something that is complex like life? Hopefully someday we'll get it more of a formal part of the course. All right, that's all I had. That's the course, right? Everybody got that?
Yeah, bro.
Yeah.
Yes, sir.
Yes, sir.
Yeah, this is great. I love it.
Excellent.
So no one else got lost like halfway through?
Yeah, no.
I
But
did.
I mean, maybe a little.
overwhelmed.
Like, you have the slides there too, so you can just read it after.
If you did understand everything I just said there, then you don't have to take this course.
I wasn't even paying attention.
Exactly, I wasn't even paying attention.
Yikes.
So it's just gives you a flavor of the kinds of things we're going to do. All right. I like how many people have their videos on. You guys are fantastic.
Were you expecting a lot less?
In the past, maybe it's because it's the first day. In the past, I found I consistently had 6 people talk to me.
That's decent, I think.
Wow.
All right. Any thoughts, fears, concerns?
I have a question, sir.
Yes.
My video is not on. Is that okay?
Okay.
Okay, now I am taking 1090 this morning with you. So
Yeah.
do you think I would still be okay in this course?
Absolutely.
And I haven't taken Java yet. Would that still be okay?
Absolutely.
Oh, I'm so happy. I really liked you this morning. Okay, I'm happy. Great. Thanks.
Periodically, I will say the word Java to mean a piece of computer code. I could just as well say Turing machine or C or something. At no point do you need to know Java. You just need to know sort of once in a while. I mean, this course is, so in both courses, I assume that you know absolutely nothing. And it's a good assumption.
That's great. Okay.
Generally, people do know absolutely nothing. And if you were in 1090 this morning, you'll see we started right at the beginning.
Yeah.
And in this class, when you watch the videos start right at the beginning. And then if there's something you say, I don't understand that, then we'll go over it.
Yeah, I kind of watched a little bit of the predicate logic, and I guess I didn't understand, but it's very interesting, and I'm looking forward to both the classes. Thanks. Thank you so much.
So question, you didn't understand what we did this morning?
No, that I understood, but I watched the videos from this class. And it was about predicate logic, and it was a little complicated, but I think I can handle it. I'll be fine.
Yeah. So let me tell you, so one of the reasons I started teaching the logic course is because people come to this course and they come to the other courses I teach, and they don't know the basics of logic, and then we struggle. So there's times when, in the past I used to make people, I covered a little logic at the beginning of this course, but this year and last year I didn't do that. Instead, what I've done is whenever it comes up in the material, then we cover it right then. So.
I see. Yeah, that's very comforting. Thanks.
Yeah. So when we get there, I'll tell you, see, this is what I need you to know about logic. Right?
Yeah.
Professor, just had a quick question.
Yeah.
I know how you spoke about Turing machines, how you can turn like a Turing machine into like a Java program, or like a Java program into a Turing machine. Does that work for any language or certain languages?
No, any language. Any respectable language will be Turing equivalent, meaning that you can compile from it to Turing and Turing back.
Sir, in your intro video, like the introduction for, I believe it was for 2019, you had also been teaching 1090.
2019? No.
No, it was one of your past videos, the ones that you had us watch before today.
I think you're talking about the predict logic, right?
No. It's just the intro to the course.
Yeah.
Yeah. So you were teaching 1090 at the time, and you said you might take some tests from 1090 and implement them into the course, or some questions from 1090 and you would implement them into the course. Are you still going to be doing that this semester?
Yeah, I don't think I shortened things even more this term, partly in order to get more time for machine learning, and partly because, well, I don't need to be teaching you 1090. You should be taking, hopefully everybody took 1090 either now from me or another time from me. And yeah, so last term I did have the first test last term was about first order logic. That's what the test was, first test. And you'll see that I deleted that, and now our first test is about Turing machines.
Okay, thank you. It's just because that, like, because you said you would take questions directly from 1090 tests and put them onto our tests. So then, since this course is competitive, like, you need to be like above everybody else. It doesn't matter your mark. So then, like, people who would be taking 1090 would have an advantage.
Well, I don't know if I said, I don't know if I ever copied questions from one to the other, but there are certainly, let me tell you that right now, let me tell you that the big thing from logic that people fail to know coming out of 1090 that I absolutely need you to know. And that's, if I said, what does it mean for a problem to be computable? If I were to say for every input, there is an algorithm that solves the problem, then I want you to feel pain in your body, because you can't have a different algorithm for every input, right? I don't want to say for every input, there's an algorithm. I want to say there exists one algorithm that works for every, that solves the problem for every input. So it's that kind of, it's those sort of games that that are gonna come up in this course. And you need to understand what a first order logic statement is.
Yeah.
Right? And so if I'm going to say right now, if you didn't understand what I just said, you should learn a little bit about first order logic.
Yeah, no, I understand. I get the point.